Hello, I'm Michael Romero, and this is a survey of cloud service providers and their offerings for COP 6819. What is cloud computing? Cloud computing is a style of computing in which scalable and elastic IT-enabled capabilities are delivered as a service using Internet technologies. A hallmark of cloud computing is the rapid provisioning of on-demand compute resources. For plain compute services, this is either done as a virtual machine or in a container. To support these images, there also has to be an associated storage capability and network data transfer. These deployments are managed over the internet via a web-based console or a command line via an OS-specific SDK. Most deployments require no intervention at all by staff of the cloud provider, though many have specific limits on what can be provisioned without a one-time intervention. Compute resources are billed as they are used, so optimal deployments will scale up when more power is needed and scale down when less demand is needed. The level of specification for these compute resources can be tailored to the customer's needs. When less detail is needed, they can be provisioned as software as a service or function as a service. For more detail, platform as a service is offered. For bare metal specification, there are infrastructures as a service. This is the Gartner Magic Quadrant for Cloud Infrastructure and Platform Services. Gartner is an industry-leading consulting and research company for technology, and one of its signature products are the Magic Quadrant papers for various technologies. The overall leader, according to this, is Amazon Web Services. They have a significantly larger share of the industry. This is followed by Microsoft and Google. To a lesser degree, they are followed by Alibaba, Oracle, IBM, and Tencent. Alibaba is of note because it has regional dominance in Asia. For the rest of the presentation, I'll be going over the offerings of Amazon Web Services, Microsoft, and Google. The fundamental virtual machine services are Elastic Cloud Compute from Amazon, Compute Engine from Google, and Virtual Machines from Microsoft. All three providers offer a Kubernetes-specific platform while also offering a vendor-specific orchestration service for containers. All three also offer autoscaling functionality, which is used to manage deployment and the teardown of resources based on cloud monitoring metrics. For platform as a service deployments, Amazon offers Elastic Beanstalk, Google offers App Engine, and Azure offers cloud services. At the even higher level of abstraction, function as a service, Amazon offers Lambda, Google offers Cloud Functions, and Microsoft offers Azure Functions. There are three basic types of storage. There are database services, which encompass relational and NoSQL databases, backup services for long-term, low-access storage, and general storage services, which include block-level storage, file-level storage, and object-level storage. Block-level storage is an access type that allows read and write access similar to how a disk would operate. In fact, the disks for virtual machines use block-level storage. This is useful for large sequential reads or writes. For more abstracted storage, there's object-level storage, which uses a unique object identifier to access a logical object in storage, and file-level storage that uses a file path to locate a resource in folders. To do anything with the compute resources, we need a way to access them. By default, resources are placed in a virtual private cloud or virtual network. These resources can either have their ports open for access via firewall settings or have a more robust virtual private network connection established. The cloud service providers also offer integrated DNS and CDN services for their products. Cloud service providers have different virtual machine types which can vary based on compute optimized, memory optimized, general performance, or high performance layouts. Overall, Amazon tends to be cheaper. Functions as a service is a newer deployment paradigm that abstracts even more deployment details away from the user. For some deployments, you only need source code in a given language to run. Functions as a service are event-driven. They are triggered by signals such as HTTP requests, timers, or other cloud services. Every time a function is called, an instance is started up and is torn down when they are finished. It is up to the functions to store relevant data in the proper place. Instead of being billed for compute resources, functions are billed by service call. This means that functions that are not active but awaiting requests will not be billed. This is not behavior that can be replicated by a virtual machine, since idle virtual machines cost just as much as active ones. When many instances of a function are launched, they can share an instance, which is one of the ways a function's behavior can become unpredictable. Another source of unpredictability is when functions are re-executed due to failure. Despite this, the quicker time to deployment makes functions as a service attractive for many use cases. One thing to note about deploying a function as a service is that there is a large discrepancy about what languages are supported by a given vendor. For example, only Microsoft can run PowerShell scripts on Windows hosts. Meanwhile, Microsoft can't run Ruby operations. Common among all the top providers is the ability to run Python, Node.js, and Java. They also all allow design of custom containers to run functions in any language you prefer, but there is the reduced ability of not using a vendor-tested runtime and the increased development time of designing these runtimes. There are other choices to consider when choosing a vendor, but language choice has a high impact. Another limitation on functions as a service vendors are the package size limits. Amazon and Google are on the lower side with 250 megabytes and 500 megabytes uncompressed, while Microsoft has a package size limit into the gigabytes. This can impact on what libraries can be included in a cloud function and may require package optimization or segmenting functions into smaller deployments. Another restriction is how long a function can run. Amazon allows up to 15 minutes for a single instance, while Microsoft allows 10 minutes and Google allows 9 minutes. One of the few configurable options besides the code is the memory allocation for a function, which is also the basis for billing. Microsoft is fixed at 1,536 megabytes. Amazon allows as little as 128 megabytes up to 3 gigabytes in 64 megabyte intervals, while Google allows as little as 128 megabytes up to 2 gigabytes. The performance and functions are linked to how much memory is allocated, and I'll go over some of them. For short cold startup time, it is recommended to use lightweight languages such as Python or JavaScript. Something that uses a virtual machine like Java has too much to load for short functions. Interestingly, Amazon doesn't seem to be affected by how much memory is allocated. So if you don't need a lot of memory for the actual operation, Amazon will be the cheaper option. For many metrics, Alibaba doesn't seem to be affected by how much memory is allocated, which is impressive for disk-bound random I/O reads and memory-bound tasks with low memory allocation, but a detriment to its start time.